Hey everyone, welcome back to Probability Theory. This will be lecture 13 of the course. And in this section, we want to define the concept of a probability distribution, specifically for discrete random variables. So let's go ahead and jump into it. And we'll call this section 2.2, Probability Distributions for Discrete Random Variables. So we're going to start by I want to start with a definition of something I think we've kind of laid out before, but I want to make sure that this is very clear. The probability that a random variable y takes on the value of y. The probability that a random variable y takes on the value of y. And we kind of write this as we use this notation, probability that y equals little y, big Y equals little y, is defined as the sum of the probabilities of all the sample points in S that are assigned the value y. Little y. Okay. Right, and so this is what we talked about last time, and we had examples where I'm thinking of like the dice example, right, where we had this y defined as the sum of a roll of a pair of dice. Okay. Right, and so we know that, what does that look like? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So this is roll 1, this is roll 2. The sum is 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, and 12, right? So if I roll a 6 on the first and I roll a 6 on the second, the sum is 12. All right, so you can think of this as the sample space for this random variable y. Okay. Now, to each of the outcomes, by virtue of how we've constructed this, we have assigned a numeric value to that outcome, right? And so if you get a 1 followed by a 1, we've assigned the numeric value of 2. If you get a 1 followed by a 4, we've assigned the numeric value of 5. And so to each of the sample points in the space, we've assigned a numeric value, and that numeric value is the value that the random variable y can take on. Okay. And so what we're saying in this definition is that the probability that a random variable y takes on the value of y is defined as the sum of the probabilities of all the sample points in S that are assigned the value y. So for example, if I want to know the probability that y is equal to 4, what I need to do is I need to look into the sample space and say, well, where are all my 4s? And so they're right here. How many of them are there? There's 1, 2, 3. What's the probability of this one? Well, it's 1 out of 36. What's the probability of that one? 1 out of 36. 1 out of 36. So this probability would be equal to 1, 36 plus 1, 36 plus 1, 36. So 3 out of 36. So 1 in 12. Now, similarly, I can do this for any of these. I can say, what's the probability that y is equal to 7? Well, I just have to look here, and I can see here's all my sample points that have been assigned the value of 7. So 1, 2, 3, 4, 5, 6 of them. So I would have 1, 6 plus 1, 6, 6 times. So, 1 out of 36, 6 times. So 6 times 1 over 36. is 6 over 36, so 1 in 6. Okay, and so this is what we mean by saying that the value, the probability that y is equal to y is the sum of the sample points that are assigned the value of y. Okay, now just a little bit on notation. When we sometimes we'll use this notation, the probability that y is equal to y. Oftentimes we will abbreviate this as just P of y. Right, this is kind of like this is sort of a longer hand, this is a sort of shorter hand. And these functions are going to be referred to frequently as the probability functions. So these are the probability function. And specifically for the random variable y. Okay. For the random variable y. Okay, very good. So that's where we're going to start. Now what I want to do is I want to lay out an example quick, and we'll come back to it in a moment. But first I just want to work through this example, and then we'll jump to the definition of a probability distribution, and then we'll return to this example. So here's my example. So let's say a work team has 3 women and 3 men. So a team has 3 women and 3 men. And they wish to select 2 workers at random for supervisor roles. They select 2 workers at random for supervisor roles. And that's an R. If you can believe it, that was an R. Okay, so a team has 3 women and 3 men. From these 6 people, they select 2 workers at random for supervisor roles. Okay, let's let y be the number of women chosen for supervisor. Okay. And what we want to know is what's the probability that y is equal to 2? Okay. All right, we want to figure out the probability that y is equal to 2, otherwise known as the probability that 2 women are selected from the 6. Okay, and so what we can kind of figure this out pretty quickly. We've seen examples like this. The total number of outcomes, that's you got 6 total workers, you want to choose 2, right? So 6 factorial over 2 factorial, 4 factorial. When you do the math on that, you'll see that's 15. There's 15 ways to select these 2 supervisors from these 6 people. Now the favorable outcomes would be choosing 2 women and 0 men. So how to choose 2 women? Well, there's 3 women total, so 3 choose 2. Okay, and that means there's 3 ways. And how to choose 0 men? That's 3 choose 0, which of course there is only 1 way. Okay. And so using this information, we can say that the probability that y is equal to 2, otherwise known as P2, P of 2. It would be this, sorry, the product of these 2 divided by this one, right? So it'd be like this, 3 choose 2 times 3 choose 0 over 6 choose 2. So that's 3 times 1 over 15. Okay, so about a 1 in 5 chance. So there's a 1 in 5 chance that 2 women will be selected for the supervisory role. Okay, now we know that the values that y can take are going to be either 0 women are chosen, 1 woman is chosen, or 2 women are chosen, right? We just found the probability that 2 women would be chosen. We could run the same exercise to determine the probability that 0 will be chosen and the probability that 1 will be chosen. Right? So if we were to repeat this for these other possible values, what we would end up with in the end is what's called the probability distribution for the random variable y. And so that brings us to the next definition. Okay, and that is the definition of a probability distribution. The probability distribution for a discrete random variable y can be represented as a formula, a table, or a graph. Right? So we haven't said what it is yet, but it's something that can be represented as a formula, a table, or a graph, which provides the probability of y, which we know is equal to the probability that the random variable y is equal to the specific value y, for all y. Okay? So when we come up with a probability distribution, what we're really doing is calculating all of the different probabilities for all the different outcomes that y can assume. Okay? So let's go back to our example of the 3 men, 3 women, 6 total people. Y is the random variable that counts the number of women selected for supervisor. Okay, and we already figured out that probability that y is equal to 2, otherwise known as probability of 2, we figured was 3 choose 2 times 3 choose 0 divided by 6 choose 2, which we said was 3 over 15, otherwise known as 1/5. What about the others? What's the probability that y is equal to 1, or the probability of 1? Well, I mean, you can think about how these choose pieces were selected. So 3 choose 2. Instead, we want 3 choose 1. And instead of 0 man, we're going to have 1 man. So this will be 3 choose 1 also. And the bottom is still 6 choose 2. Okay, and so this would be 3 times 3. And so you get 9 out of 15. Okay, and that's going to be 3/5. What about the probability that y is equal to 0? Well, that's the same as the top, isn't it? It's 3 choose 0 for the women, 3 choose 2 for the men, and 6 choose 2 for everybody. So 3, 0, 3, 2, 6, 2, and so 3 over 15 equals 1/5. And so because y can only have the values 0, 1, or 2, and we've calculated the probability of each of those, we now have the probability distribution for y. And so it can be represented in various ways. So the first way you can represent it, maybe we'll start with, is a table, right? So usually if you're representing a probability distribution as a table, you want basically 2 columns. You want y, and then you want the probability of y. Okay, and so we said y can be 0, it can be 1, or it can be 2. The probability of 0 is 1/5. The probability of 1 is 3/5. And the probability of 2 we found to be 1/5 as well. Right? So this is a probability distribution for the random variable y, okay, in table form. Okay, this is in table form. Now we can also represent it as a graph, right? So we could say, here's my axis, and we'll come up like this. And let's say we want, what do we want here? 1/5, 2/5, 3/5, we'll say. So on the horizontal, we've got the values of y, so these guys. On the vertical, we've got the probability of y. Okay, and so we know that we've got what, 0, and we've got 1, and we've got 2. Right, so the probability of 0 we said was 1/5. Probability of 1 we see is 3/5. And the probability of 2 is also 1/5. Right, so we can see that you got this nice sort of histogram. Some people may refer to it as a bar chart. It's really, I would say histogram is the better way to describe this. All right. And so you can look at it this way and kind of have the numeric values straight, right in front of you, or you can look at it graphically and you can say, oh yeah, I see 0 is 1/5, 1 is 3/5, 2 is also 1/5, right? This gives you a sense for the distribution of the probabilities, how they're kind of laid out. And yet a third way to do it is to write the probability distribution as kind of a function. And so sometimes that's easy, sometimes that's very tricky. But in this case, if we kind of look up here, we can see that it's really the same form over and over, right? And so what we got to do is just figure out how to plug y's into this to make this make sense as a function. And so the way to do that is to say the probability of y is equal to 3 choose y times 3 choose 2 minus y, all divided by 6 choose 2. In this case, that's what it looks like. And this is a valid function for y equals 0, 1, or 2. Right, so notice if you put in a 0, you get 3 choose 0 times 3 choose 2 divided by 6 choose 2. And that's exactly what we have up here. If you plug in a 1, you get 3 choose 1 times 3 choose 1 over 6 choose 2, which is exactly what we have here. And then obviously if you plug in a 2, you get 3 choose 2, 3 choose 0, 6 choose 2, which is exactly what we have up here. Right, so this sort of formula here is another way to write the probability distribution. Okay, very good. So that is what we mean by a probability distribution. Now, it's important to notice that for probability distributions, the fundamentals of probability have to be adhered to. Specifically, 0 needs to be less than or equal to the probability of y, which needs to be less than or equal to 1 for all y. Right? So all values that the all values that the random variable can assume have to meet this property, right? We can't have negative probabilities, and we can't have probabilities for a particular value greater than 1 either, right? And secondarily, if I sum over all of the probabilities given in the probability distribution, that needs to be equal to 1, right? Meaning that some outcome is certain for the random variable y. Right, and of course you can see that here, right? So obviously these are all between 1 and 0, so that's great. Also, you note if you add them up, you get 5/5, which is 1, right? And so you meet both of those criteria for your probability distribution. All right, very good. Let's do the example of finding the probability distribution for our pair of dice rolls. Okay, so here we'll say that y is equal to the sum of a pair of dice rolls. Okay, and so we just laid this out a few pages back, so you can reference that. But we know that y is in the set, what is it, 2 through 12? 2, 3, and so on up to 12, right? So there's 10 values that the random variable y can assume, right? So let's write this out as a table first, right? And so y can be equal to 2. That's like I roll a 1 and then I roll another 1 and I get a 2 when I add them together. It could be 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. So those are the possible outcomes for this random variable. And if you just reference your table, you'll see that there's only one sample point in the sample space that corresponds to 2. So the probability of 2 as the random variable equal 2 would be 1 in 36. Okay? And it turns out, if you look at your sample space, you look at the previous page, you'll see that for 3's, there are 2 ways, and for 4, there are 3 ways, and for 5, there's 4 ways, and 6, there's 5 ways, and so on. So this is a very orderly probability distribution. So you've got 1 out of 36, 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, and 6 out of 36. So for 7, there's a 1 in 6 chance of the random variable 7 appearing. Now after 7, it goes back down, right? 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, and there's only one way to get a 12. So 1 in 36 chance of that, right? And so you can see clearly if you look at the sample space here, there's one way to get a 2, 2 ways to get a 3, 3 ways to get a 4, 4 ways to get a 5, and so on. And then you can see on the other side of 7, it starts coming back down, right? Okay, so we can see the structure of the sample space really nicely. And so this would be the probability distribution for this particular random variable. Now we can also represent this as a sort of a table, right? So let's say I want to put a 6, 5, 4, 3, 2, oh sorry. Let me rewrite that. So 1/6, 6 out of 36. I apologize, folks. Let me put it down here. So we've got 6 out of 36, 5 out of 36, 4 out of 36, 3 out of 36, 2 out of 36, 1 in 36. Okay, so that corresponds like these hash marks here. Okay, and then I'll cross the side here. I'm going to just put all my values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so this is the values of y, and this is the probability of y. Well, actually, I meant to put that down here, so that's okay. We'll kind of bump this up a little bit. So this goes up here. Everything's kind of getting shifted up. Apologies. Okay, so 2, we saw this 1 in 36 chance. 3, we saw there is a 2 in 36 chance. 4, there's a 3 in 36 chance. And then a 4 in 36 chance. And then a 5 in 36 chance. And then for the central value 7, there is a 6 in 36 chance. Okay, and then the probabilities kind of descend on the other side as well. Okay, and so you can see, for example, if I were to say, what's the probability that y is equal to 5? All right, I can look down here and I can say, what's 5? Okay, it's right here. So it's that one, 4 in 36. And I can also look over here in the table and I can see it there. Okay, so it's available in both places. Now, in the case of this one, how could we represent this as a formula? Well, there's probably different ways to do it. The way that I can see to do it is to say like this, kind of do a piece function. Right, and so we could say that the probability that y is equal to y minus 1 over 36. And this works for all the values less than or equal to 7. Right, so 2, 3, 4, 5, 6, or 7. Right, so if I plug in a 7, it's 7 minus 1 over 36, so 6 over 36, which is indeed what it is. And for the other half over here, we could use 13 minus y over 36, and that would work for 8, 9, 10, 11, and 12. And so this is one way to represent it as a formula. All right, very good, very good. And so that is what we mean by the probability distribution of a discrete random variable. It is basically just a table or a formula or a graph that provides the probability of y for all values of y that the random variable y can take on. Okay, and so that is where I think I'll end this lecture. And in the next section, we'll get into something called the expected value of a random variable. And so until then, take care.